Hello again, this is Mr. Underkoffler. This time I'm going to be going through the guided notes on multiplying and dividing monomials. Now, I apologize, I did not put the definition of monomials here. Monomials is referring to simple algebraic expressions with no addition in it. You'll see variables, you'll see possibly numbers, multiplication, but that's pretty much it. And I'm going to do this lesson with a little bit of a discovery piece to it, so that way you can see for yourself how the math actually works. And I'm going to start first with multiplication problems, as you can see here on this slide and also on your guided notes download. The directions say to simplify, which means make it as simple as you can. In problem number 1, you can see we have x to the second and times x to the third times y to the sixth and times y. And what we're going to do is we're going to use the meaning of exponents. You should know from what you've learned about exponents that x to the second would mean x times x. X to the third would be x times x times x. Y to the sixth would be y times y times y times y times y times y. Hopefully I said 6 of them. And then y with no exponent seen at all was just going to be y. What you can now do is count how many x's do you now have. We have 5 of them, so with multiplication in between, this x piece here would be the same as x to the 5th power. And for the y's, all of these y's here multiplied together would be the same as y to the 7th power. We can write this in simplest form without keeping the multiplication dot in between, and we get x to the 5th times y to the 7th. Problem number 2 is a little bit different. We have some numbers involved. So 5 is just 5. 14 is just 14. What would m to the 4th be? Well, it would be m times m times m times m. M to the 2nd is just m times m. We can use our commutative property of multiplication. Put the numbers next to each other. 5 times 14. Put all the m's next to each other. 5 times 14 would make 20, and all of these m's would be the same multiplied together as m to the 6th power, and that's how you can simplify that expression. I would like for you to now try problems 3, 4, and 5 on your own. So hit pause, try these problems on your own, and then hit play when you're ready to see my results. All right, hopefully you have done that. Problem number 3. You write out all these h's using the meaning of exponents, and this would simplify to h to the 6th power. Problem number 4. The work would look like this. Use your commutative property. All these a's would be the same as a to the 4th, and all the b's would be the same as b to the 8th. Problem number 5. Write out all the u's. The 18 and the 2 stay as 18 and 2. You can use your commutative property. 18 times 2 is the same as 36, and all these u's multiplied together would be the same as u to the 9th. Now, if you're sitting there and you're like, oh my goodness, do I have to write out all this work? I've already discovered a shortcut. I'm glad you have discovered a shortcut. Let's talk about this shortcut that I bet a lot of you have discovered. When you multiply like bases, when I say like bases, I mean like x's times x's, y's times y's. You can do a very nice shortcut. You can add their exponents together. Now the base stays the same. It's not like x to the 2nd times x to the 3rd becomes like z to the 5th or xx to the 5th. It's just x to the 5th. You can add the exponents. 2 plus 3 is 5. That becomes x to the 5th. So the base stays still being x. And we can now use this shortcut to do problems in a much quicker fashion than what we were doing above. Let me lead you through number 6 and 7. In fact, this is already typed up on your guided notes. We have 3 to the 2nd times 3 to the 8th. Based on the shortcut that I just spelled out for you that we had discovered, we can take the exponents, add them together. The base is still the same. It's still the base of 3. And that gives you 3 to the 10th power. Number 7, we can take the commutative property, put the 5 times 11 on the left, and then w to the 6th times w. Now, let's talk about the details here. The W that we saw by itself is the same, not as W to the 0, it's the same as W to the first power. And so now with that understanding, we can say that this becomes W to the 6 plus 1, which is W to the 7th power. The 5 times the 11, they are not like bases, but they're just whole numbers. We can multiply them together and get 55. And that is why this simplifies to 55 times W to the 7th power. All right, now that I've led you through number 6 and number 7, try 8, 9, 10, 11, and 12 by yourself. So hit pause so you can do these problems on your own, and then hit play when you're ready for me to go over the work and answers. All right, I hope you've done these problems on your own. Problem number 8, I would start by using the commutative property so you can get the m's next to the other m's, those like bases. Now with those like bases, you can add their exponents. The n is not a like base with the m, and that's why the n to the second stays as n to the second. Final answer, m to the 13th times n to the second. Problem number 9. Again, use your commutative property to get all those x's next to each other. The z to the 14th power, I'm just going to put it over there on the right, using my commutative property. Now we can take the shortcut we learned, add the powers of the x, and the final answer is going to be x to the 13th times z to the 14th. I'm not sure why my z started looking kind of fancy here, but whatever, bear with me. There you go. Problem number 10. Now this one you have to be a little careful. The c's that you saw without any exponent being shown, they are not c to the zeros. They are c to the first powers. And therefore, when you add the exponents, you have to be adding the ones for the first powers of those c's that we saw initially as just regular c's. And that's going to make this final answer c to the 16th, not c to the 14th. Problem number 11. The 15 and the 4 were not like bases, and they had no exponents. We're just going to use our commutative property and put them here on the left. The d was the only d that we saw, so that is not a like base with any of the other variables. We do have like bases with the k to the second and the k to the 6th. So I'm going to put them next to each other using my commutative property of multiplication. And now I can use the shortcut that I learned for multiplying like bases. I can take the k to the second times k to the 6th and actually add their exponents. 15 times 4, they are not like bases, but they are whole numbers. I can multiply them together to get 60. And now I can put everything together. The times dot is not needed when you write this in simplest form. And you get the final answer of 60, d, k to the 8th, q to the 5th. Problem number 12. Now this one was written with parentheses, but what does it mean when there's parentheses next to parentheses with nothing in between? That means multiplication, as we learned earlier this year. And since everything inside of the parentheses is also multiplication, we can basically use the associative and commutative properties to rearrange this expression. Put the numbers next to each other, the negative 22 times 3. The r's, put them next to each other because they are like bases, and the v's, put them next to each other because they are like bases. As I've taught you before, when you see a variable by itself, that is the same as the variable to the first power. And you will need to know that since you have another r here being taken to the 4th power if you want to use the shortcut that we have learned earlier about adding exponents when you multiply like bases. So r to the 4th times r to the 1st is r to the 5th. Or sorry, I'm skipping ahead. We can add those exponents. We can also add the exponents for the v's. The negative 22 times the 3 is negative 66. Final step, r to the 4th plus to the 1st is r to the 5th. Add the exponents for the v's, we get v to the 28th, and you can see the final answer here is negative 66, r to the 5th, v to the 28th. Next page, let's discover how we can simplify division problems where there are exponents involved with the variables. Now, to remind you, a fraction bar is a creative way of showing a division problem. So that's how this is being shown here. We are once again going to discover how this works by using the meaning of exponents, where x to the third is the same as x times x times x. X to the second is the same as x times x. Likewise with the power of y's. We can write that out using the meaning of exponents. Y to the second is the same as y times y. And now we can use something we've learned from earlier in elementary school. Anytime that you take a number divided by itself. Now remember, variables represent numbers even though we don't know what that number is for that variable. But anytime you take a number divided by itself, it would give you 1. And so what happens is that x divided by x can cancel out. Cancel is kind of a generic word. You're really dividing itself out because x divided by x is 1. And that happens there. It also happens here. But it doesn't happen anywhere else with x's. And again, it happens with y divided by y and another y divided by y. Now, what do we have remaining that I did not highlight in purple? We have a single x, and we have 4 of these y's being multiplied together. And that's why the final simplified version of this answer is x times y to the 4th. Take a look at number 14. We have 14m to the 9th over 2m to the 3rd. Once again, I'm going to write out the powers of m using the meaning of exponents. But the 14 did not have an exponent, neither did the 2. And so what you can do here is do 14 divided by 2, which will give you 7. But with the m's, you can do the same thing I was doing back on number 13. You can divide out an m from the numerator with an m from the denominator because the fraction bar means division. And do that as many times as you possibly can. Now, the remaining m's in the numerator have no other m's in the denominator that you can divide them out with. So, count. How many of these m's do we have remaining? We have 6 of them. And since there's multiplication in between, that can be written as m to the 6th power. And that's why this expression simplified to 7m to the 6th power. All right, I would like for you to try to do numbers 15, 16, and 17 on your own. Hit pause, do these problems on your own, then hit play when you're ready to see the results. All right, let's see how you did. Number 15. We can write out x to the 6th. We can write out the meaning of x to the 2nd. We can divide out 2 different pairs of x's from the numerator with the denominator. We have remaining x times x times x times another x, I hope I counted that correctly, in the numerator, and that would be x to the 4th power. Problem number 16 works out very much the same. U to the 7th we can write out. The denominator just stays as being the u. We can take a u from the numerator, divide it out with a u from the denominator, and you are left with u to the 6th in the numerator for the final answer. Number 17 is kind of like problem number 14 from above. You can write out the meaning of the exponent for the a to the 8th and also a to the 2nd, but the 20 and the 5, they're just numbers, not taken to any exponents. We can just simply divide them. 20 divided by 5 is 4. But with the a's, you can take 2 of the a's, a times a, divide it out with the other a times a from the denominator. The numerator still has 6 of these a's being multiplied together. And so that is the same as a to the 6th power. Now, once again, there is a shortcut, and I bet a lot of you have already discovered what that shortcut is. The shortcut is when you divide like bases, you can subtract their exponents. The base will stay the same. So please don't think that when you take a to the 8th divided by a to the 2nd, that somehow that becomes 1 to the 6th. No. The base still stays as a, but you will subtract the exponents. 8 minus 2 will give you 6. Let me take you through a couple examples, and then you'll do the rest of these on your own. Number 18, let's use the shortcut that we just learned. Such a quicker way of doing these problems. And that is when we divide like bases, remember the fraction bars mean division. When you divide like bases, you can subtract their exponents. So, problem number 18. We are definitely dividing like bases. So we can subtract their exponents. 10 minus 3. That will give you 7. Now, the base still stays as W. It doesn't become 1. Don't think W divided by W, because this was not just W divided by W. This was W to the 10th divided by W to the 3rd. We are using the shortcut here. The base stays the same, but we subtract the exponents. Problem number 19. Same type of thing as number 18. The base will stay as 16. But we can use the shortcut that we have discovered and subtract the exponents. And that's why this becomes 16 to the 3rd. Now, 16 to the 3rd, we can actually take that a step further. 16 times 16 times 16. I would probably honestly use a calculator for that. And that would give you 4,096. I would like for you to now do numbers 20 through 23 on your own. Hit pause on this video, then hit play whenever you're ready for me to go over the answers. All right, I hope you've done these problems on your own. Let's see how you did. Problem number 20. We can subtract the exponents and get a final answer of x to the 5th power. Number 21. Again, we can subtract the exponents, but do not accidentally think that this is going to become a 1 for the base. No, 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 no. It's still a base of 9, but the exponents will give you 9 to the 3rd power when you apply the shortcut of subtracting the exponents. Now, 9 to the 3rd power means 9 times 9 times 9. 9 times 9 is 81. Times another 9 would give you 729. Number 22. The parentheses here do matter. I talked about this a little bit in the previous lesson of guided notes on negative exponents. So the parentheses here have to stay around the base of negative y. But you will subtract the exponents just like we've been doing from using the shortcut that we've talked about for dividing like bases. Final answer, negative y still in parentheses taken to the 28th power. Number 23, the like bases, let's do them separately. M to the 6th over m to the 5th, you can subtract their exponents. U to the 11th over the u. Now, remember what you've learned before. When you see a variable and you don't see an exponent on it, that is the same as that variable to the 1st power. And that's why you're going to be doing 11 minus 1 when you subtract the exponents of the variable u. All right, let's finish this. M to the 1st times u to the 10th. But you know what? You can take this a step further. M to the 1st is the same as just m. And since the direction said to simplify, and the word simplify in mathematics means make it as simple as you can, then that's why number 23 should go that extra step. M to the 1st is just the same as m, and then we have the u to the 10th power. All right, that's the guided notes on multiplying and dividing monomials. We'll see you next time.